was accurate based on the feedback that we got from students. And so if something isn't clear, please ask. I'll do my best to answer. Don't ask me too difficult questions because I'm not a lighting expert. So cove lighting. Also, speaking of lighting, would you prefer these lights dimmer? Yes. Is that okay? So cove lighting. I suspect that a lot of these terms are familiar to you all. I could be very wrong. So cove lighting is an indirect uplighting that provides overall diffused illumination from a cove to a ceiling plane. Cove lighting is generally used as a secondary ambient light source to add dramatic effect and or emphasize form. Next year, when you're in fourth year in advanced studio, one of the things we do is an activity and presentation with students about lighting. And so you'll hear us talk about layers of lighting, which basically means different types of lights, different placement of lights, different switching of lights, but all within a particular space so that it can be lit in a variety of different ways for a variety of different reasons. If you look at that image, like I think and hope it's pretty clear where the cove lighting is, but you can also see that it's not the only source of illumination within that space. And so especially when you have a larger space, and especially when you're dealing with public spaces as opposed to private residential spaces or private offices, oftentimes in a more public or shared or group space, you have a variety of different types of light. Even in this very perfunctory space, you've got a couple of different types of light going on in here for, again, different purposes. So essentially, you have a little shelf that sticks out from the face of the wall, kind of high up towards the ceiling, and as part of that shelf, the lamp or the light is placed, and then you have a little lip that essentially covers and conceals the fixture itself so that you just get this kind of glowing feel and illumination. So the intention of cove lighting is never to actually see the bulb itself, but it's only to actually just create ambient light. A cove is a ledge projecting from a wall or ceiling where a light source is placed. Linear fluorescent or LED strip lights are used in cove for evenly distributed light. So just like in this example, you can see that on either side of that conference room, the light looks very evenly distributed along the length of that cove on either side. But placement of light in cove is critical to avoid shadows or hotspots. Check manufacturer spaces for recommendations. And so what is meant there is that when you're dealing with linear fluorescence, like I don't know if you can appreciate, but there would be like linear fluorescence in each of those fixtures. That's typically what you have in a corporate office or a acoustic ceiling tile configuration. It's typically when you see those types of fixtures, they're typically linear fluorescence. But in a cove like this, what you have to kind of appreciate is that the light fixture, if it looks like that, then the housing for that light fixture often looks like that because the power comes into this part so that it can be transmitted into the bulb. But if you want to have like this long, consistent, constant illumination like that, it's difficult to have another placed like this because there's no illumination coming from that. Can you appreciate that? Like illumination comes from this part, the actual bulb. And so over here, if we have another bulb, but then again, this is going to create a little bit of a shadow. And so essentially, as it says, like you have to pay attention to the manufacturer's installation because depending on the manufacturer, this distance might be really big, it might be very fine, and sometimes in plan, you will actually, if this is a plan view, you might actually end up staggering this a little bit so that you don't get that overlap, if that makes sense to people. And so this image is going to probably make its way, not the image itself, but essentially one of the details that you're going to be creating in in your final project, one of the details is going to be a cove light. And so this kind of configuration will look familiar in your own drawings. So color temperature. Who taught you lighting? Was it Julie?
Yeah.
And did she talk a little bit about color temperature?
Yes.
Okay, good. And so hopefully this is going to be more of a review than it is going to be new information. So Kelvin is the unit used to measure the warmth or coolness of a particular source of white light. The higher the Kelvin, the whiter the light. And so, the little illustration I think is kind of helpful. But in terms of the numbers, 2,000 to 3,000 kelvins, you're going to get a soft yellowish glow. 31 to 4,500 kelvins is a brighter white light. 46 to 6,500 kelvins, bright amount of bluish white light similar to daylight, and upwards of 6,500 kelvins, bright task lighting, and it's the brightest light. So I just kind of want to quickly skip ahead to this image. This is the same kind of space. It looks like it's a work environment because you've got task chairs and a work surface. The space is pretty white, and so I think, as bad as the lighting is in here sometimes, and as bad as the resolution is on the projector, I think it's pretty discernible the difference that exists between those three differences in quantity or amount of kelvins. And so, what would you say would be the more ideal for a corporate office? The left, the middle, or the right? I would probably lean more towards this one because really there is a warmth here. To me, if anything, this feels a bit more cozy. Oftentimes when you're in a corporate office or a workspace, you want things to be very crisp and clear. When you're looking at something, you don't want to have to squint. There's like a softness there that doesn't exist here, and so that might be a bit more comfortable, perhaps, for the lounge in an office environment, but something like this to the right, I think, is going to create a better work environment. Kind of like this room right now. Before I dim the lights, like we can all see, we can look at papers, and I think we can read a piece of paper, but I think it's just going to be a little bit easier with the lights turned up full level to actually work, maybe not on your computer, but on paper. And so just something to be aware of. So yeah, actually we go back here at the bottom, it says high visibility office, 5,000 to 5,700K. And so as I mentioned, that's likely going to be in this range and produce that result. A lobby is going to be between 5,000K. Corridors, 35 to 4,000. And so you can appreciate that the amount of work that we do in a corridor is a lot less than the work that we would do in an actual office space. So you do have to consider the kind of work or function prior to selecting the lighting, and it does, as it say, impacts the occupant mood, which is a lot of times why in our residential spaces we don't have fluorescent lighting, because that would feel a little bit more severe and harsh, and it's why in residential lighting we often have lamps, or sorry, not overhead lighting, but yeah, like lamps. It kind of creates more of a warmer and cozy feel. Considerations for cove lighting when you're detailing. The light source selection will determine where it is placed in the cove. So again, understanding the actual light spec that you choose will implicate the placement of it. Generally speaking, the lamp should be a minimum of 3 inches from the wall to avoid bright and uneven lighting. So, and we've got that communicated here. Top of the lamp should be level with the cove or fascia, it will create shadow lines. So I think that's pretty clear, it just has to be parallel. Ceilings are painted high reflectance matte, often. Inside of the cove is painted flat white to avoid unnecessary reflections. And so, typically speaking, you do not want a ceiling that produces glare. Given that lights are going to produce their own glare, you do not want to have a finished surface that's also going to be shiny and create a harsh quality when you happen to look up. A recessed tray ceiling. So coves can extend from the wall as a ledge or a tray illuminating the ceiling above. Center portion of the ceiling is often added in a different material to add contrast, such as acoustic ceiling tiles. And so that's the example that we have here. And so, you know, we actually have 3 different light sources here, and as perhaps plain and unexciting as this particular office is, or conference room or meeting room is, you have 3 different sources of light. You have these 2 pendants that are suspended above the table. You have these 2, probably more over outside of the photograph, recessed downlights, and then you have the cove lighting around the perimeter. And so once again, this dimension here can vary depending on the design. You know, in the previous slide, we talked a little bit of projecting a certain amount from the wall, but in this instance, it may not have to do with the wall. It may have to do with central design and kind of creating this central component to act as a focus so that the table is a focus and we're paying more attention to what's going on in the center of the room than we're paying attention to what's going on around the perimeter of the room. A drop ceiling. As you all know, you can drop or suspend the ceiling, and therefore you can use light to highlight that design move. Ceiling can be dropped and light projected on both the ceiling and the wall, which is kind of what's going on there. We have light that looks like it's going up, but we also are getting some residual light coming to illuminate the surfaces around it. This type of lighting emphasizes the geometric form and defined space in pretty much anywhere. It says lounges or waiting areas. It can happen anywhere, quite frankly. And so this is the kind of configuration. With the light placed here, we're actually illuminating this horizontal ceiling surface here, but we're also illuminating the upper portion of the actual wall. And again, the lighter this is painted, the more reflective that light is going to be. And so you just have to determine how much of a light source you want that to be, or is it going to just highlight a design detail? Are we actually gaining any light that supports what we're doing in the space, or is it more really just to accent the fact that we have created this different or distinct ceiling surface, and we just, from a design point of view, want to highlight and accentuate that? And so this is probably starting to look a little bit familiar with some of the things that you guys have already done in this class with me. So you can see you've got your channel and studs, channel attached. You've got another channel, stud, channel, attached, attached. And so it's important for just this simple bulkhead to remember that every piece of drywall, every end, needs to have something solid to connect into. And we've also got drywall happening all along here. But what we have drawn here is a little bit different. So here we have drywall suspension system, the main T or cross T. And so one of the things that I'm going to talk to you guys a little bit about today is the fact that there are I say? There are contractor ways of creating certain solutions, and then there are manufacturer ways of creating those same and identical solutions. And so um, this solution to me looks more like a manufacturer as opposed to contractor or builder, because this looks like a prefabricated piece of material with all of these highly individualized and sized and placed openings within that. So here I think that I've already shown you this image in another class. You have your drywall ceiling, you've got the furring channels, and on top you have the rolled channel, and that is spaced at 4 feet on center. So from here, 4 feet, 4 feet, and so on. And then the tie wires actually wrap around this channel and hang from the structural ceiling above. And so that's how those ceilings, again, are able to stay in place. So this is a very similar detail. There are a couple of drawings, quite frankly, that will not be posted, and I can't recall this might be one of them, just because it's very similar to what you have, what's required. But I will review it with you, and I just want to hand out a couple of things. So if you have a pencil, that's probably not a bad thing, or some sort of writing device. And so please just double check that I'm giving you 2 pieces of paper and that they're different from one another. I don't think I missed anybody. So let's just have a look at this. So a lot of times people get confused about the wood versus metal studs that we have in construction. Typically speaking, wood studs and wood blocking are only used for residential. And we have metal studs used for corporate, commercial. But the one thing that you can appreciate, hopefully, or I can make you appreciate, is that there are instances where wood blocking is still used. And I don't know if you can tell because of the hatching that's on here, but essentially this rectangle you see with the X through it, which suggests wood blocking. And then I believe there is another one here. Again, it's difficult to see with the diagonal hatching that has been drawn, but that is another piece of wood blocking. And so you can, as designers, incorporate wood blocking into your commercial spaces. It's just you can't use wood studs and plates for the whole construction, just because there's so much more likelihood that that will burn much faster than if they're metal studs. Obviously, at least at this stage, maybe there will come a day where we can't use wood anymore in our designs and everything is going to have to be metal. But in a scenario like this, you're welcome to use a little bit of wood in the construct. But the main structure, again, the main structure is still coming from the steel or metal studs. So yeah, it's not so bad here. But you you can get a sense of what's going on. Again, you've got the channel, the stud, the channel. We can attach here, we can attach here, we can attach here. We've got another channel here. We've got a furring channel, and so that connects there. We can assume that that construction continues on after the break. But because of this little piece, because that little channel is going to take some space, and we know that the tie is going to go around that member, we still need to have some wood blocking in this corner so that the drywall can connect here and here. And even though this little lip around the cove isn't large, we still probably want to finish it with drywall, and so we need something modest in here for the drywall to nail into, and it's probably going to be just as efficient and easy and cost effective if we use a piece of wood blocking as opposed to another bit of metal. So again, just remember, the main structure of this surface is coming from these furring channels and this member that attaches to the furring channel, and then this other portion here, which is supporting the back of this cove. So this is connected to the ceiling, and these are connected to the ceiling. This drywall is still attached to the metal. So this surface is attached to metal, this surface is attached to metal, this surface is predominantly attached to metal. So metal is the predominant structure there, but where we have these little gaps and spaces where the drywall has nothing to connect to, that's where we add the wood blocking. Does that make sense to people? I'm hopeful. And so I think this is one of the handouts that I just gave you, and so why don't you guys see what you can come up with as a solution for this little guy. Which, again, no tricks. It should be pretty similar to what the image that I just showed you on the slide previous. So in a couple of minutes, I'm going to randomly select someone, and they're going to come and sketch it on the board. see anybody today other than Shea? I don't think so. Celine, pick a number between 1 and 14. Number 10. Chloe, tell me which student is number 10 on the sheet. Don't worry. Just tell me. If that's the door and those are the window, which student is number 10? It's Isabel.
那为啥要让你教？那跟你没有什么关系。
Any and all colors that you need.
我看你老花的，我看你老花的，我看你老花的，我看你老花的。
So, what do we think? Do we give her a thumbs up, a thumbs down, or thumbs somewhere in the middle? I also give her a thumbs up. Good job. And so basically, you can sit if you like. So we've got some wood blocking here. We've got some wood blocking under our channel. We've got the end of we've got this channel here, assumedly at the very end of this structure, there would be another channel there. We've got a furring channel here. We might have another furring channel here, depending on what that distance is. But we've got this, and I'm just going to highlight this a little bit more, Isabella. And so this is like what's tying all of that together and what's ultimately suspending it to the concrete slab above. And so this is exactly what I would hope. Again, we've got another channel here, another one here. So there's some structure here, there's some structure here. We've got the wood blocking at either ends. Again, depending on the manufacturer, depending on the design and what is visible, you have to remember that the only part of this that's visible to the people in the room, this is what's visible. I don't know if that's really showing, but these are the only real surfaces that are visible. That's not a visible surface, that's not a visible surface, that's not a visible surface. It's not likely that that's visible. This probably isn't visible either. Again, it just depends on where you're standing in the room. Maybe your eye is only going to be able to go up here. Maybe if you're standing very far, your eye would be able to go up and see that. It just depends. But to be honest, most people aren't going to walk randomly around like looking at the ceiling, right? Like as a designer, it's okay to do that once in a while just because you want to know and learn and see how they've achieved something from a spatial point of view. But yeah, this can vary depending on the scenario. Part of the decisions are based around the manufacturer's requirement of the kind of space that light needs to do what it needs to do. So, great. On a reflected ceiling plan, the edge of the cove is shown with a solid line, and the light fixture inside the cove is shown with a hidden line. Many, many years ago, when I first started here, I would teach Detailing 1, and I developed the Detailing 1 course for this program. And I don't know if it's still the same or not, but it used to be that you would have you would draw the master plan, and then you would make several copies of it, and you would have a furniture plan that would be drawn on the copy. You would have a RCP or a lighting plan drawn on the copy. And in the lighting plan, I remember that the symbol we used to use for fluorescent lights or lighting underneath the cabinet was very similar to this. Was a symbol like this at all used in your It was in Detailing 1. And so I just wanted to make sure that it was a familiar symbol, that it's a continuation. And so again, one of the reasons that that symbol is used is because on some level, when you look at this plan, that actually looks like it might be almost the size of the fluorescent light. But the other thing that's more important is that there's this continuous or consistent kind of quality along the edge, just like what we would want cove light to be. We want that light to be uniform and consistent along the length of it. And so this is pretty much how you're going to draw it. So again, this line here, that solid line, is going to indicate the edge of the surface of the drywall, or it doesn't have to be drywall, it could be a different material, and then that is going to be the cove around it, the actual light, if that makes sense to people. I think too, one of the things, and I don't think I'm going to require you to do it on this particular submission, but I think it's very important for you guys when you start doing a reflected ceiling plan to make sure that you actually note the heights, the differing heights that you have in that space, because you could have this scenario, you could have that scenario. There's lots of different possibilities, and so when you do start changing the ceiling height levels, it becomes increasingly important to denote that on a floor plan. So, for example, here we've got 8 foot 0 inches. There we've got 11 foot 0 inches. To be perfectly honest, I'm not 100% sure how that's even possible, given that this looks like one continuous structure, and that has not been broken. I'm not 100% confident about why that's 8 feet and why that's 11 feet, but at the end of the day, you should note. So for example, in here, we can see that this is 8 feet. We can can see that this is 8 feet. We've got another ceiling height indicated here. I can't quite make it out, but essentially you need to, wherever ceiling height is changed, you need to indicate that. But I do feel in this instance that either the 8 foot is a mistake and that is correct, or this should have been off to the side. But I think within this corridor, there's some 8 foot ceiling heights and some 11 foot ceiling heights. Unfortunately, I think in this instance, it's not clear to me where the 8 foot is and where the 11 foot is, because it looks like it's on the same plane, and that's obviously not possible for one thing to be 2 different heights. Just something to keep in mind. So just a couple of visual examples of cove lighting. Again, consistent illumination. We've got lights underneath the cove. We've got lights with the ACT. Again, ACT can be used without this kind of regular fluorescent drops. Another version. And so look how the lighting is in this space. Obviously, this light is so bright that it's going to illuminate and actually reflects and mirrors the shape and organization of this table. You've got additional light here. You've got another cove light happening along the wall. We've got these kind of recessed down lights, but the placement of them is a bit atypical. I would have expected to see another recess down over here. We've obviously got a little bit of a breakout kind of lounging area there, and so the intensity of the light doesn't need to be or create as much of a focus as the central illumination does. And then another slide and image of cove lighting. This is probably like very familiar to you. I feel like this is something that we see in a lot of retail environments. We just don't even think about it. And so that's it for that PowerPoint. I have another one that I'm going to go through with you. And it is this one. And so maybe on the back of one of the pieces of paper that I handed out to you, look up at the ceiling above you and sketch what you see. Include the components, such as the underside of the structure, the main beam, the cross tees, the hanging wire, and the ceiling tiles. So I would start by, towards the top of your page, have a line that's just straight across that represents the concrete slab above. And then if we look, it's kind of like you just want to see here the lighting. So I think we can assume that the main tees are the ones that has the longest length, and the cross tees are the shorter ones going perpendicular to that. You'll have the ceiling tiles or the acoustic ceiling tiles and hanging wire. Just as a note, in my experience, it is often that at the intersection or at an intersection is where the hanging wire is going to be attached, because that is where two things come together. And so you're going to want to have the load of each of those two directions supported by the wire. And so, again, I would just draw this as kind of like a section view, not in a three-dimensional view, but in like a section view. So have the line above indicating the concrete slab, and then start to think about these cross tees. going to make you guys sketch that out in front of the class just because we haven't really reviewed it, but I think it's good to try and observe things and see how you think that they go together. And so I'm just going to continue on, and you'll kind of check your own drawings against some of the images that we have here. Suspended ceilings consist of acoustic ceiling tile, or ACT, as you already know, and a metal grid system. The system is supposed to be versatile, durable, sustainable, and cost-effective. And so I think the other thing that's really important is right now, this creates kind of a false ceiling. It's good for absorbing sound, but it's also good in case something happens with the building systems above. Like, you can see how some of the cabling has come through. Like, we stopped it here just literally so that we could have like a portion of the space as a teaching moment. Before we moved to this campus, it was actually the request of your interior design faculty that half of the ceilings be as this and half of the ceilings be like this, so that it was very visible, and that solution was given to another program. And so we don't have that great idea for whatever reason. But essentially, the ACT is great for this lighting, it's great for acoustics, but also these acoustic ceiling tiles are so lightweight that we can just pop them up, and a contractor or a maintenance person can go into the ceiling, deal with any issues with the cabling or any kind of other issues there. And so it's just very convenient. Hopefully you can appreciate that if this was a drywall ceiling, it would be bad for acoustics. We very likely would not put this kind of fluorescent light in a drywall ceiling, and we also wouldn't have the access to the plenum space above. And so this kind of ceiling is really good when you have a lot of technology up there where there's a likelihood that things are going to need to be fixed, repaired, updated, that sort of thing. And again, it's very easy and pretty much cost-free for somebody to just tap up these panels and stick their head and shoulders up into that space. If this was all drywalled, that would actually have to be ripped open and repaired, which is going to be messy, costly, and impact, your schedule or the space or what goes on in there. So again, this is not a section, but this talks about the individual components of your T-bar ceiling. So again, you've got the hanger wire, which attaches to the metal frame and is connected to the slab above. You've got an edge molding. The edge molding isn't always used. It's actually used in this space because we've got an edge. Normally, the T-bar ceiling is going to go from wall to wall, from wall to wall, but in this instance, the edge of that T-bar ceiling is exposed. It's not beautiful, and so we've just got essentially this trim piece here, which you can all come and look at a little bit later if you're so interested. The ceiling tile, which is the ACT, pretty obvious. The main beam and the cross T. Again, the main beams are typically those that don't have as many breaks. The cross T's are the ones that always break. And so you can see the joint here and the joint here. There's a joint here and a joint here. If you could, you would see that there's a joint here and there would be another one here. And so the main T's are considered the main because they are the longest and therefore the most structural. And then the cross T's are the ones that are just the length of the actual tile itself. And so the T's have different profiles. Right now, we have a square edge in this room. Because why? Because it's the cheapest. And it's also the most basic. It's not necessarily the most beautiful. I would say that this scenario here is very likely the most expensive and the most pleasing visually because you have very little interruption. Here we see this component. Here that component is hidden, and so this surface ends up looking a lot more uniform with the exception of this little design element here. these are similar and that they're both tabular edge, which means that the actual tile itself is recessed so that instead of this kind of standing down, it actually is recessed in, and so the panel face drops down below that T, and from an aesthetic point of view, again, it looks a little bit more finessed or a little bit more refined, and that's just because it's a more expensive solution, and the basic nature of the T-bar isn't the prominent detail. The tile becomes the detail. And here, there's just like a little bit of a beveled angle to that. And so that's pretty typical. But again, the square edge is going to be the cheapest, most basic that you can get. Here, this suggests that the wall. And so you have to support, just like you need to have in the Cove Light, all of the edges of the drywall need to be supported with structure underneath. Because this is just acoustic ceiling tile, it needs to kind of have like a lip or a tray all around it. And so at the wall, there's no opportunity to have like the regular T, right? And so you have this angle molding or this L molding. And this is essentially the same thing, but this little odd shape here creates a little bit of a reveal, and it kind of creates a little bit of a shadow line, which is why it's called shadow molding. And again, this is going to be a titch more expensive than that, but that little reveal is just going to create a little bit of visual interest in comparison to the cheap solution that we have here, which is consistent with that kind of T system. So you're welcome to look at armstrongceilings.com. I'm not going to go into the website, but basically the next few slides will kind of orient you around Armstrong. If you want to go and look at it now while I'm doing this, you're welcome to do so. If not, you can look at it later. And so Armstrong is a pretty big and common and reputable manufacturer of acoustic ceiling tile ceilings. And again, it's a pretty comprehensive website, ceiling grids and whatnot. And then it gives you a little bit more specific information with regards to the specifications for different types of ceilings. And, sizes, dimensions, the kind of materials, that sort of thing. There's spec sheets that you can also download. You won't be required to do that for this project or for this course, but just for your future reference. We've got a drywall ceiling grid as well. And so the one thing, and Aubrey, I see that you're excited about that, and that's great. Unfortunately, that will not be something that you will be using for this project, but it's something that you can be aware of for use next year in Advanced Studio. But for the purpose of this project that I'm going to review with you after the PowerPoint, I only want you to use Armstrong for the ACT, not the drywall. And I stipulate that in the assignment brief, but I just want to make sure that people are aware. But yeah, and so it's interesting. For sure, I am old school. Like, obviously, I'm twice all of your age, and I kind of have the mentality that as a designer, I don't want to fob off my designs to a manufacturer. I want to design it. But I know that we're living in a time now where things are mass-produced, and we're looking for efficiency, and things are just very different than when I was a young designer. Now, I feel like designers design less and specify more. And I'm just old school. Like, I like the design. I don't like to give up that control to somebody else. But I do think that we're moving away from what I would like and moving more towards prefabrication. So it's just something to be aware of. So I like this drawing on the right in purple, not because it's purple, but just because it's the drawing. And so you kind of have like the above view of your acoustic ceiling tiles. And so you can see that when you have like a light within the system, it's framed slightly differently because obviously a light is going to have some weight, right? The ACT, the acoustic ceiling tile, is pretty lightweight, but a light fixture is going to have a lot more weight, and so as a result, it needs to have additional support all the way around it. So you can see this grid right now is probably 5 by 5. Do you guys know like the basic grids that they're usually a grid of 5 by 5 or 2 by 4? And so in here, I can't quite tell, but I would suggest, I don't know. I can't tell if that's, yeah, this I think is 2 by 4. But some instances, like in this instance, I believe that, I'm not sure actually. Maybe, oh, I think it's framed differently because they've put a fixture of something in here. Maybe this isn't a light fixture, actually, maybe it's something else. But essentially, you've got your typical grid, but I guess based on the design of what was below, this element had to be located outside of the confines of the grid. And so it's been structured slightly different here. And so it's just kind of interesting, but you have to remember that regardless of the placement of your cross tees and main tees, that something that's heavy, even this grill here, that all of the tees around it, again, whether it's the cross or the main, that is supporting the load. And so especially in each of those intersections, you're going to have a tie at each intersection that's going to go up to the ceiling because that's where a large part of the weight and load is, and so it really needs to be supported at those points. This is drywall, sorry, that's my bad. This is drywall. I was thinking that this was ACT, it's drywall. And so yeah, this is just the framing of the drywall by Armstrong. But again, I'm showing you this just for your information. This is not what I want or expect from you in terms of your project that I'm going to review with you. But this exists. You will very likely use it in the future, and so it's good for you to know. I'm going to require you to use your traditional drywall framing for the project, but you can see the difference in that kind of scenario. And look at all of the little holes and perforations. That's so that you don't have, the contractor doesn't have to make holes in the metal themselves. And yeah, it creates a little bit more flexibility from the prefabricated part. So again, traditional drywall framing versus Armstrong drywall framing. Prefabricated, contractor fabricated. Essentially the same solution, just different components. Obviously the drywall is the same, but the metal components are different. Like a metal contractor can easily get those studs and furring channel. Did I say metal contractor?
Yes.
Sorry. A contractor, he can be human, he doesn't have to be made of metal or she. The contractor is going to be able to get those metal components very easily and readily. A contractor is not going to be able to get these components easily and readily. They have to be ordered as part of the materials at the beginning of the project. But yeah, steel studs and all of that are so readily accessible. But yeah, like, I certainly don't expect you guys to remember CAN 12, like that component, that's very specific to that, but you can see that the componentry is just, it's very similar. It's just the sizing and names are quite different. And so this is actually, I don't know if it's taken in this room or the other room, but this here is actually the trim to the ACT that I was talking about, because again, the edge of that isn't going to be particularly pleasing, and so you've just kind of got this cap or trim that just goes to the edge. more Armstrong ceiling trims and transitions. And you can see here how it's used around the edge, just like here, except this is obviously a nicer environment. But you'll see that there's different types of trims and whatnot. I actually think that this was a photo that was also taken in one of our washrooms. I could be wrong. A pocket light or a soffit light, again, has typically a very particular task. It's often towards the corner of where the wall meets the ceiling, and it is intended to directly illuminate the surface below. Oftentimes, that's at where the toilet connects to the wall or the sinks connect to the wall, just because, especially from a maintenance point of view, we want to make sure that our washrooms are very clean, and so having them illuminated where there's water and waste and that sort of thing, that illumination in that point is going to be the most effective resource for the janitor or maintenance crew to ensure that those spaces are clean in the critical areas. So again, the light source is concealed at the edge of the ceiling and it illuminates the wall. A metal baffle covers the light source, which is this. Sometimes that's plastic, but I do believe in this instance it is metal. This detail is often used in public washrooms to illuminate a sink and a mirror. And so this is a little bit like that, except here, like in this image prior, this grid is flush and at the same level as the drywall. In this image, it's a little bit different because there is no grid here. So a grid, in theory, could be applied here, and that little frame could be added. And so I think I handed that out to you guys as a little handout. You're welcome to sketch it out if you like. But again, just remember that we're not going to be using Armstrong ceilings for drywall applications, that this is just to show you. This is also a drawing that comes directly from their website, so this is for your benefit. So if it's okay with you, I'm going to review with you your last project for this course. So, much like wall-type ceilings are designed to address specific criteria. The larger the project, the more likely it is that you will need to develop your ceiling design to address varied lighting requirements, acoustic priorities, and the shaping and aesthetics of the space. Cove lighting, suspended ceilings, and bulkheads are all ceiling strategies that can be used to house lighting, address the sound absorption, and vary the experience of space. It's important to consider the function of each individual space or room and plan the lighting and ceiling strategy accordingly. The distance from the top of the floor slab to the underside of the ceiling slab, as well as the depth of the plenum space, must be known and addressed in the design process because that's an important part of the space. A lot of times people just plan space based on the floor plan, but really, in my opinion, and in fourth year, you guys will not just design your plan and then elevate and be done. You will design 75% of your plan, and then you will design in elevation as opposed to just elevate what's there. So that will be one of the differences that you experience next semester, because my understanding of your third year is you plan, and then you just elevate and make it pretty. Do you design in elevation or do you just elevate? People are quiet, and so I'm thinking that you just elevate. And so next year, I'm happy to let you know that we're going to help you figure out how to sculpt space. You're still going to have to deal with adjacencies, space planning, and all of those things. But space isn't two-dimensional, it's three-dimensional, and so you will plan the space in the third dimension as well. Project requirements. So, part of the ceiling study will be completed on a large format, not unlike what you handed in today. 18 by 24 RCP from your corporate studio. Please plot a clean RCP on bond. For the purpose of this submission, you must incorporate a bulkhead with lighting around the perimeter of at least one enclosed room. You will also incorporate at least one suspended drywall ceiling that incorporates acoustic ceiling tile. And for your third detail, you'll do cove lighting around the perimeter of at least one room or space. So in case it's not clear, you're going to be doing 3 details of ceilings. Some of you may already have these elements incorporated into your studio RCP design. If you do not, this is your opportunity / requirement to further consider the design and incorporate these requirements. So if those are 3 elements that are already a part of your initial design, great, bonus. If they are not, you must modify your design so that you have addressed all 3 of those different conditions. On your plotted RCP drawing, ensure acoustic ceiling tile ceilings and gypsum wallboard ceilings are clearly identified. And you're welcome to just identify them with GWB and ACT. That should become, those letters should become part of your legend. Something else that should become part of your legend is heights. Like just a little box or what have you with like some X's in it to indicate, and I'll just show you what I mean so you don't think I'm crazy. Just like you have this for a room number, and then in a legend for a partition plan, that's typically a symbol, and you would have in your legend room number. And so maybe in this instance you'll use, because we don't have room numbers, I'm fine for the purpose of this exercise for you to use the same symbol. Just put it in the legend. You can use this, although this is typically used for room numbers. That's typically used for door numbers. Maybe you've got like something else. I don't know. You don't have to reinvent the wheel. just make sure that whatever, which suggests the dimension in feet and the dimension in inches. So just make sure that this is your that the symbol that you have on your drawings is part of your legend and we understand what that symbol is referring to. Okay? Also on the RCP drawing, create a neat legend directly on the drawing using distinct colors to identify bulkheads, suspended drywall ceilings, and cove lighting. So can I just make a request, please? Like when you're using your colors, and I'm not sure what I'm going to find today, because obviously I haven't looked through them yet, please use very distinct colors. Like these are distinct. Don't use like mauve and lavender and plum. Those are all nice colors, but they're hard to differentiate. So use primary colors. Don't worry so much about the aesthetics. Right. If you already have these three requirements incorporated into your ceiling design, please still highlight them with color and the legend. The ceiling type study will be reviewed by your professor for completeness and accuracy. Next class, after the quiz, that is what I will be doing. And so if you want to have this ready for me, that's what the class is going to be. It's going to be quiz for the first little bit, and then I'm going to work with you individually just to make sure you're on the right track. It's not a check off that's worth marks, but it's also something that I will be doing only in this room. You will submit the hard copy ceiling study drawing as process work in your final submission. Please understand that when I look for process work, and I'm not sure if it's different for your other professors, when I'm looking for process work, I'm not looking for perfection. Like, I'm looking to see your thoughts, and if your line isn't perfect or what have you, I'm fine with that. Process work to me is you working through things. I can see some of your mistakes or where you changed your mind. That is fine. Process work is not intended to be beautiful. The final drawings need to be crisp and clear and professional and thoughtful, but your process work is like literally your thoughts and figuring shit out. It doesn't have to be made pretty. And so I just want to make sure that people are aware of that. Other instructors may have different requirements. Using the handout provided in class and also resources available at Armstrong Ceilings, complete a rough draft of ceiling details mentioned above. And so you can also include that as hard copy. And so this is the important paragraph. We encourage your research. Again, I should change the we to I because it's only me teaching this semester, but it was Leo and I last semester. I encourage your research into different ceiling systems and manufacturers. Excuse me. However, for the purpose of this project, the only manufactured components allowed for these three detailed drawings are those that are indicated on the main components ACT slide in the PowerPoint. And let me just remind you of which ones those are. They're on the other PowerPoints. So really, the only things that I want you to use from Armstrong are the things that can be found on that slide. So those are the only Armstrong products that you are allowed to use in this project. Okay? I honestly don't know how much more I can make that clear because it's in the brief and I am trying to go through it in a way that's clear because I'm not going to be able to give you good grades if your entire solutions are from Armstrong because that's just like pulling from somebody's website. Like I want to see you guys think and compose and that sort of thing. purpose of this project, only the manufactured components allowed for these 3 detailed drawings are those indicated on the main components ACT slide that I just reminded you of in the PowerPoint. You may have additional ceiling elements or detail in your overall RCP design. You can include them or highlight them in your RCP study or not. This is completely up to you. But for the purpose of the submission, only the 3 ceiling details mentioned will be required for your project. So again, the bulkhead with lighting around the perimeter of the room, suspended drywall ceiling with ACT, and cove lighting around the perimeter of the room. Prepare CAD detail drawings to industry standard scale for these 3 ceiling details. So you're going to include a line of the ceiling slab or the structure above, line of the adjacent wall if it's appropriate to the detail, including the fastening components, finished ceiling construction, material components, annotations and leader lines indicating specific materials and thicknesses where appropriate, applicable hatching and line types, line weights, reference symbols, title, scale, etc. Your ceiling detail can be named this way. I'm going to see about finding some examples right in this moment, and I'm not sure I have them. So I'm going to finish reviewing this. You're going to give me 2 minutes to see if I can find some in my files, and then I will show them to you. Right now on this, it says that details should be drawn in 3 inches to a foot or 1.5 inches to a foot. I'm not confident that the 1.5 inches was big enough, but I want to bring up some of the examples just so that I give you guys one direction instead of confusing you with 2. Unlike your wall details, which were portrait oriented, these details are going to be landscape oriented because hopefully you can appreciate ceilings are horizontal. The majority of the detail will also be in a horizontal way orientation. You may need to use cut lines in order to fit the drawing on the sheet. Some of you, hopefully all of you, use cut lines in your wall details. Projects will be, again, submitted both hard copy and electronically via Slate in the appropriate Dropbox. Submissions are only accepted in PDF format, merged and compressed. You'll also have a cover sheet with course information, bind with 1 staple in your left corner, much like you did today. Again, I'm not sure whose this is, but I would much prefer to be stapled just because it's easier for me to access. Please save your PDF in the following format. So this project is worth 30% of your grade and is due at the beginning of class in week 13. Process work is worth 3%, and each of the details is worth 9, and then you can see what each of those is comprised of. It's essentially the same thing, that the detail is correctly drawn and complete with all components properly identified. Use proper graphic and drafting standards, dimension and annotation style, line weights, and line types. Detail is contractor ready, meaning that a contractor can be presented with detail and know exactly what to do and how to build it moving forward. Any questions, comments, concerns, or complaints? And I can be open to complaints if they're delivered equally. And so I'm just going to disconnect so that you don't see all of my secrets in my files, and then I'm just going to see if I can find you a decent example or 2. And so, just give me a few moments, please.
轻的，又轻的，这样都好这些，不是因为有时候你知道吗？我用的久那种多少之类的，反正从台湾带来的，久了就你这样贴上去，它整个浮起来，它不贴，这个是久了就好多年后就会很熟了，就是我要用 就是可能知道吗？对，反正因为反正我就觉得啊，这个感觉质量很好，我觉得都6、7年了，我还不如再买个新的。我也不想在国内买过，这是我目前用的最好的，这个多少？而且还挺小的，4块多，400，8，好贵啊！但是真的还蛮好的，价钱。
这个可是蜡烛。
看来怎么也有个4到6之间吧，应该有4。我不想的那些太旧了，就胶布刺来就是这种效果。对呀，我想，对，你们好有才，我以前都是这样的。我第一次听到有人拿初中、高中都是这样过来，是拿胶带吗？就是痛胶带，双面胶带，还是痛的？那你还，那你比如说你字写那么急，你还得先把，因为我们没有
兄弟们，T8我们要不要 hatch？
你说啥作业？
底下那个东西要不要 hatch？应该要 hatch 吧？
你在说哪个作业啊？
在说我们的那个，不是，哦对 elevation。
什么？healthcare。不 hatch 啊 ，elevation 怎么会要 hatch？对啊。
elevation 没有任何，不要挡我镜头，录完发。往那边。往安那边，往安那边。
So here you have one detail, and so we will go with 3 inches to a foot, not 1.5 inches. It's too small. This you can see down here is 3 inches to a foot. We have another ceiling detail. This one shows the acoustics T-bar with the drywall. And then we have another one which shows this kind of drywall with this little detail of the light over there. So this is kind of what we're looking for from you guys.
就不需要用 hatch。
I think it's relatively straightforward, or at least I think it is. And you can see where all of the actual lines are connecting the drywall to a surface. Sorry, Aldo, the time for questions and complaints is past. Just joking. No, I'm done. Are you done with me? Is that what you're saying?
No, my question is, all details are called ceiling details. Do you rather us call like?
I would rather you identify them by the name that I have in the assignment brief. I think that's a great question. I'm not going to mark you wrong, but it just kind of aids in the professionalism and kind of the habits that you guys should be getting into with drawing packages. So great call, yes.
So I think we need to use the hatch for those.
I agree with you. This one does not have hatch. This one is an example that has some hatching. I would say that the hatching in this example is a little too dense. It almost looks like a concrete board. And so, I know, like, yes, I'm sure, is this what you're laughing at down here? I was like halfway, so that's one of the reasons why I didn't show that example. But it does have the hatching as was indicated. It's a little better there, although I'm not sure what the drawing number. I'm not sure that this was an example. Actually, the hatching here is decent. Yes. Because what do you want to make sure? Because I'm not posting these examples.
I know, just can't see.
But what is it that you were wanting to see?
I'm looking at the labels. This? Yes.
it's still pretty standard. It's the basic elements that were there, right? Like, I don't think that there are any additional elements that we haven't reviewed or any tricky elements. Like, literally, all of those are there. This says structural blocking. Do you see where it says structural blocking? Please don't put structural blocking. You can put blocking. Structure is going to suggest that it's holding up a wall. The blocking is there to help for shape. It's there to help create the shape. But structure,
哪儿大家做的都不一样是吧？各种各样。
blocking is exactly okay because blocking is what it is. But structural blocking suggests something different.
So for that ceiling detail, you want us to incorporate
就跟今天画的这两个差不多。
So if we look at, so we have a bulkhead with lighting around the perimeter of the room. We have a suspended drywall ceiling with ACT. So that has both, right? And that's what the detail has, right? And then the last one is a cove lighting around the perimeter of one room, or one space. So first one, a bulkhead with lighting around the perimeter of the room. So okay, so this is an important question, and so I want to make sure that everybody's ears are turned on. Do you know, at this stage, the difference between a bulkhead and a cove?
就扣子包进去。
People are looking at me like I'm going to tell you the answer, which I can, but the question is, do you know the difference? I
不能
Yes.
这个就是包开，这是
So
扣。
the difference is, a bulkhead doesn't necessarily need to have light in it. It is just something that is dropped into or down into the space, usually around the perimeter, but not always. And then in this instance, your bulkhead is going to have lighting. And so there's going to be a light fixture underneath the surface of the bulkhead. So this drywall kind of mass that projects into the corner of the room is also going to have light coming through that part. Whereas a cove is more to do with, even though a cove is often attached to the ceiling, it may not be, but in this instance, if we attach to the wall, so the light is going to come out from the side, not from below. And again, suspended drywall ceiling with ACT, that middle detail doesn't say anything about light. Doesn't say anything about light. Doesn't say anything about light. It's just, how does the drywall and the ACT meet? Other things that you would like for me to clarify, review, repeat, explain differently? How, on a scale of 1 to 10, do you think you did with this? And obviously everyone's going to answer a little bit differently unless you all copied off of each other. But was it a reasonable assignment? I don't think that this should be that much different. And again, this is due